code problem, Reorganize string. So for this problem, you'll be given an input string S, and you need to rearrange the characters in the string so that none of the two characters which are next to each other are the same. So here's an example where they've given a string with the characters A, A, B. So if you put A, B in the middle, the characters A are not next to each other. And they've given another input where it's not possible to have a string where the two characters are not adjacent to each other. So in that case, we return an empty string. So yeah, this problem has been set as a common Amazon coding interview question. So yeah, to solve the problem, the first thing we are going to do is we need to keep a count of how many times each character occurs in the string. And then we need to use a data structure to retrieve the most frequently occurring character. And we keep appending it to the string and then get the second most frequently occurring character. We keep appending it. And we keep doing that until all of the characters are used. So yeah, let's see how we can solve it. First thing we'll do is create a hash map and keep a count of how many times each character occurs in the string. So we'll just use a for loop to traverse down the string. So yeah, we retrieve the character at the index I, and now we just check if it already exists in the hash map or not. So if hm Yeah, so essentially what this does is we are building a hash map where we have a mapping of how many times each character occurs in the string. Next, we are going to use a data structure which is the most frequently occurring character in the string. So for that, we'll use a priority queue. And we need to define the algorithm to use. So we want something as a max heap where the most frequently occurring characters is stored at the top of the heap. So for that, let's define it here. Yes, essentially what we have done is we have created a max heap. And we use hm.getB to just say that we want it to be stored in the descending order. So using the hash map, we have already got a mapping of how many times each character occurs in the string. And by defining this, what we are going to do is that the most frequently occurring character will be stored at the top of the queue. So now we'll just add all of the characters inside of the hash map. So now that it's done, we are going to start the algorithm for actually processing it. So we are going to use a greedy algorithm. So what we're going to do is we're going to take the most frequently occurring character, then the next most frequently occurring character, keep appending it. And so we get rid of the ones which are the most frequent. So that way it will be easier to process it. And we keep doing it until all of the characters are processed and we have a complete string. To store the string, we'll use a string builder since that's the most least expensive operation. So we'll use it for appending characters to the string. Now let's first retrieve the most frequently occurring character. So And now we'll just update it. Since we have used one of the character once, we'll just append the hash map to reduce the count of it. So now that we have got the most frequently occurring character, we'll start looping through the remaining characters to retrieve the second most frequent, try appending it to the string and keep switching between them. So yeah, let me type it to make it clearer. So while not. Since we've used it, we'll also update the count in the hash map. Yeah. So now what we're going to do is we are going to add the character the value of previous back into the priority queue with the updated count of it. So if yeah, so to explain what's happening is that the first thing we did was we retrieved the most frequently occurring character and we appended it to the string. Then here we started retrieving the second most frequently occurring character. We appended it to the string builder. And now the previous, which has already had been removed from the priority queue, we just check if the count is greater than 0. So if there's more characters, we add it back. And we keep switching until all of the characters in the priority queue are processed. So now at the end of this, there's a possibility that there's one character which is left out. So this is a character where this occurs where no solution is possible. So this happens if if hm dot so if it is greater than 0, that means it has a few characters left, and we are not able to find a solution where the two characters are not the same. So we return an empty string. Else let's try running the solution. So yeah, both the use cases have passed. So yeah, the time complexity, so any operation involving a priority queue are done in log n time. So the operation will be n log n, where n is the length of the string. And for space complexity, also it's O of n, since we're just using a hash map to store a count and a priority queue to keep adding an element and determining which is the most frequently occurring one. So where n is the length of the string. So yeah, leave comments and let me know if there's easier solution to implement this.